jah,
nüüd on nagu tunne nagu päris palju.
jah, veits.
Süvariigina mitte tavaliselt näeme maski peale.
jah. Okay, let's start. Welcome, Siim. Siim is head of data science at Bolt, and you haven't worked in data science since birth. How did you how did you end up in data science at first place?
I didn't study data science. I studied public economics in Tech first, and then I went on to study econometrics in the UK. But when I was working, I constantly sort of picked up on the programming side. I was inspired by Jaanibi during my studies to pick up R first. And then it sort of happened gradually that I got, so before joining Bolt, I tried to build my own company where I did some credit modeling with large data sets. So Excel wasn't really an option, and did some predictive models as well there. And then later on, I joined Bolt to do sort of this part-time team lead, part-time technical role. And I actually got really into the technical part there because the types of problems Bolt has are quite unique and not many companies have that. So I worked for a couple of years purely as a sort of individual contributor in machine learning part and computer vision and predictive models as well. Yeah, and I sort of learned most of it while working actually, especially on the sort of programming side and software engineering side. Maybe some preparation during my studies at statistical part and econometrics, sort of linear optimization problems.
Thanks. No, I said that Bolt is a very different scene for machine learning than a university, as we often have to beat some benchmarks to get published, but you have to beat your competitors.
Yes. Well, that's a very good point, actually. So oftentimes, if you look at the Kaggle competitions and these public competitions in general, the winning works usually sort of over-optimize on the data set. Mm-hmm. And what you see in the real world is constantly, actually, when you start, let's say, developing a new model that uses some data that your apps generate, you often see that there are a lot of data issues. The data you have for training the model doesn't always correspond to what's in the real world. And also people behave differently in real world also, that when you sort of start influencing their behavior, they will adapt as well. So you need to constantly monitor your models, see that they still apply. And also Bolt, for example, has this, so very rarely we have a single model for like predicting, I don't know, arrival times or some sort of price elasticities and so on. We mostly have hundreds of models actually of same kind that we retrain for every city. So there's a considerable engineering effort, and when you need to train that many models, you need to you cannot even manually debug every model before training. So you start to think about the simplicity of the models, how you can that you know that you would that the system in general would work also when you scale. So you're not necessarily thinking how you would in this competition or sort of benchmark setting.
Thank you. For example, when I use any of the Bolt apps, so instead of did I understand correctly that you have hundreds of models competing to make a prediction for me?
Not necessarily. So hundreds of models comes from the fact that, for example, if you take maps related models like predicting arrival times or some, routing specific stuff, then cities are quite different. And we constantly keep on adding cities, which means that if you need to retrain the model every time, then you are quite you need to it's quite challenging. So what we do is we train a model usually for each city. So the amount of models, let's say you have the arrival time prediction model, that gets retrained for every city where Bolt operates. So this means that it's physically like a different model, but with the similar architecture. When we talk about like making these competing predictions, then there are fewer models. Like when you make an order in a ride-hailing app, for example, there are a couple of models around dynamic pricing. So we need to know how much demand and supply will there be in the future, so we can utilize all the drivers and get the best sort of service for the customers as well. So there are a couple of different models involved in that order flow, for example. And then on the maps related stuff, there is we predict the arrival times, and based on those we do the dispatching. We want to get let's say the best driver for you, and dispatching itself is sort of a optimization problem in the marketplace. And then, for example, the routes as well, we need to, because we predict prices up front, we need to know approximately where the driver is going to sort of drive. So in the order flow, end to end, there are quite many predictions, but not hundreds.
But I imagine the data size will be huge. So you're not. Are you what percentage of data that you have access to you're actually using to train those models? Or how do you select the data?
We actually experiment. So there are. You're right. There's the data size can be huge, but it doesn't mean that it necessarily adds to the performance. And what we see as well is, for example, if you take a city, then the situation changes quite dramatically from month to month. For example, you suddenly get snow, then everything changes, right? The driver arrival times get longer, you start taking different routes. So what we do in most cases is actually we test out what is the, so we test most of the models periodically to have the latest data. So that's actually adding a lot of value. And then we're experimenting with different sort of trailing periods. So do we use just last week of data, or 2 weeks, 3 weeks, or 12 months? It really depends on the business problem, but we sort of approach this experimentally. We see what, you can back test this. You can see, like, if you would train on the last 3 months, would it work? And then you pick sort of whatever is clever for that particular use case. Because if you have hundreds of models to train and you want to use all the 12 months data for that, it's a huge cost in terms of computation and just purely the training time as well. Because in Tallinn there are, I don't know how many cars we have, but Bolt operates also a lot of its businesses in Africa, and large cities like Johannesburg or Cape Town or similar, Durban, Lagos. Even training with 3 weeks of data is quite challenging.
Okay, but how is, for example, taking this snowstorm that we had, I think few weeks ago? Then how does it look like that? in 1 hour the streets are clear, and in 2 hours you will have huge jams. Do you have someone just waiting to press the button to switch the models, or?
Not quite. So how traffic modeling usually works is that people correlate with different names, but there's something called the hot traffic and the hot traffic. That's how we call it internally. So cold traffic is what is the historic average speed in this road segment in this time of the day and this day of the week, sort of. And maybe there's a monthly seasonality as well. I'm not entirely sure. And this is historic sort of travel times, and it depends on how often you update those. Because we get the data in from our drivers, right? So we could, and in many cities we have a substantial amount of drivers, especially in the city center. And then the hot traffic one is the real-time adjustment, and there are sort of different approaches you can take to that. So, yeah, these sudden improvements generally tend to increase the errors because. And it increases those errors everywhere. So I think these general purpose routing and map services like Google, Microsoft, and Open Maps as well, they are probably more tuned to those hot traffic as well, because they have a wider scope of users.
Okay, thank you. And while we're discussing that, I think all the questions are welcome from the audience.
Yeah, absolutely.
Too. So if you want to jump in, just make yourself audible. And the same to the Zoom, to the people who are following us at Zoom. So just unmute and try to speak, or type in the chat if we can't hear you. But I hope we can. Okay.
I can maybe jump in for a question. Maybe what is often interesting for students. That so as you told, so nobody is born as a data scientist mostly, and I'm also pretty sure that most the microphone is here, right?
Yes.
That I'm pretty sure that you know, if you have a great programming skill, you can learn a great deal of stuff. But if a student after graduating comes to work for Bolt, so what's the day like for them, or basically what is the entry level kind of task? So what do they have to know? What do they have to do? What kind of environment they are coming into? Just as a practical example of Bolt, so it can be different in different companies, but for example, in your case.
So you're absolutely right. Different companies define the data science role very differently. And it's sort of like an umbrella term that people use to speak about data analysis, data engineering, building the pipelines, also doing predictive modeling and sort of deploying those models. And also statistics, experimentation, sort of presentation is a big part of that. In both, the data science team is what I've seen is a bit more closer to the engineering side, because most of the problems that we solve are pretty big in terms of scale. So this complexity of having multiple models in different cities, for example, and being able to sort of manage the process of deploying the models, monitoring, retraining, sort of debugging them in complicated situations, that requires quite a lot of sort of just programming skills and software engineering as well. So at both, sort of computer science would be good to have, but some people have picked it up on their own. I have, for example. So it's more about the motivation of the person. Then statistics is also quite important, because we do a lot of experiments. So before we actually deploy a model and roll it out fully, we usually do some either sort of silent live, where we sort of test the infrastructure in the backend, or even sort of roll out gradually and then experiment and run an experimentation to see what's the impact on the business, on the user metrics, and so on. So these are actually key skills technically. So statistics and programming, and then machine learning as well. But you could say data analysts sort of do that as well, right? Which is true, but it's more sort of computer programming heavy on the data science side, because you're building systems that will scale. What is quite important for the data scientist is also, that's actually one of the key differentiators. You can have purely statistical skills, machine learning skills, and computer programming skills, but it's important that you also understand the business side and are willing to go into sort of this product management mode and think of the real world problems end to end, because it doesn't matter like how much effort you put into the technical complexity or building up a really scalable system. What matters is that you solve a problem in the real world at the end. And that's actually, the more early on that people are in their career, we've seen that it's a bit more challenging, because you haven't worked in this environment, and maybe some of the ways of thinking is you're not used to that, because you're not, that's not usually what the study is about. You're more, learning the technical skill. So that's usually where people need to, fresh out of university, need to learn the most. And that's what we pay attention to as well when we hire. During the hiring process, we try to sort of validate the technical skills and just general people skills, like, are you able to take feedback? Are you able to learn and sort of implement new methods? But also, like, we call this sort of the product thinking, but it's sort of a useless label. No one knows what it means actually, but it's more about, taking sort of this end-to-end ownership of the problem and figuring out usually the simplest solution. We very heavily want to emphasize that. So even at our scale, like, deep learning is rarely the answer. In some cases it is, but usually there's a simpler version that will solve the problem like 90%, which is sufficient for most cases. But it's understandable. It's easier to scale sometimes. So these are sort of the qualities, but the day-to-day work really depends on what is the product team that you end up working in, because there are so many different areas where we have data scientists working, or machine learning sort of engineers. For a while, we used to have only like structured data, which is essentially tables. But increasingly more, we are starting to build sort of these in-house services that use like unstructured data as well, like computer vision, natural language processing, and some sort of unsupervised learning as well. So the day-to-day tasks can be really different depending on the product team you end up in.
So no blockchain technology possible in both programs. So if you mention deep, there is no deep learning, then obviously there is no.
There is deep learning involved, but not
very little.
It is very big for very, like, computer vision, almost,
Unavoidable.
You cannot think about, you have analytical methods as well, and people usually don't know about them. But deep learning usually is a very robust way how you can solve those things.
But maybe we can continue follow up on the product thinking side.
Mm-hmm.
So let's imagine, and really for the students to understand the process of how it would go. So we can even let's play a game in a way that so I'm a junior data scientist at Bolt, and I can see some. So my question would be on the line that not just to understand the business needs, but to be able to propose a new business value and how it gets propagated to the decision makers in a way. So if I'm a data scientist, I'm playing out, I have this, all the routing problems and dispatching problems and so on. But I really understand, for example, just as a crazy idea, that where the parties currently are on Friday evening. So, and I have this feeling that instead of just having this destination, I could answer. So if somebody would just ask that the destination to be next party or take me anywhere where it's cool, and I know how to answer that, where would I go inside the organization? Should I go to the, how do I start it? Because then probably I'm in a wrong team who doesn't work that as a product. What happens then? And how do I keep pushing my business and product idea that we should add this, I want to visit next party. So, or the other way around, not just where to go, but just anywhere, but take me away from here. All kinds of, what were originally the taxi parts.
So the main thing that we always sort of keep in mind is what is the value for the business and for users. So in that particular case is, and sort of it's role independent, like all ideas are, it doesn't matter who comes up with them. It's more like, how do you explain it and justify that we should do this and not anything else, because the context that Bolt and most companies that actually usually operate in is that there's no lack of ideas. Like all the ideas that we do have, like people come up with those. Like we have a lot of smart people. The main question is, you have limited resources and you want to grow the company as quickly as possible. So, and you have loads of ideas. You have like tens or 100 times more ideas that you would ever sort of imagine that you would want to do. But how to pick the ones that are right for our specific needs today and give us the best sort of next step. And this is whether it's a data scientist or a product manager or just a software engineer, you need to quantify that impact somehow. So if it was this sort of party idea, like, okay, how many people out of all the rides, how many rides happen during where people go to parties, right? What's the share of that out of our total sales? Okay, then if we were able to improve that experience somehow, how much? Like, are we able to like dramatically improve it, like orders of magnitude, or just a little bit? And okay, what happens if we improve it? Do we either get more rides per happening at that time, or like, do we intend to activate some of the users who would normally maybe not ride, or whatever this idea specific things there might be. And then when we are able to sort of size this impact in a somehow rigorous way, we can compare it against all other things and then sort of estimate the cost. So this is sort of the product thinking and product framework we're at.
But in your hierarchy, where would that kind of a person go? To you or to the some chief product officer? Or...
So Bolt has cross-functional teams, which means that in every team there is a product manager, there are software engineers, sometimes data scientists, sometimes data analysts, sometimes operations people, designers, whatever is needed in that team to sort of deliver the functionality. And usually in those teams, you can propose the ideas, and ideas come from different sort of sources as well. Like that's not unusual. When there's an idea about something else, maybe about another team, then you can actually just go and talk to those people. It has happened multiple times. Like not every team has data scientists, and that's actually one of my roles now in this sort of head role. That there are many teams that just get created. There's no need to do like machine learning or some complicated experiments at first, but if either someone from the team or we as a data science function have thought about sort of solving this idea, then we work together with those product managers or software engineers that when the time is right, that these ideas would get done. And the fact that, so the data science is built up such that it reports inside engineering. All data scientists report in data science organization, but they're placed into different product teams. And we have a pretty active community internally where we discuss those different ideas. We talk to other data scientists in other product teams, and oftentimes we actually suggest we have some common discussion about maybe dispatching in ride hailing, but we need to dispatching also in food delivery. And these data scientists communicate with each other, and maybe they do a joint project for food dispatching, for example. Quick last question, if you allow me.
Yeah.
So with data science and analytics in general, it's often the question, so when to stop. So you can keep advancing all the time. It feeds back to your earlier position that you actually don't, you need the simplest answer, most effective. There is some plateau at one point, and you don't need more. So how do you deal with such cases where you just, to just tell them, or is there like a function, or basically like a process within the data science function that you will say that just pick up that the data science function from that product team and say that enough is enough, or you can't, obviously this cannot be, but there's no need to further enhance this.
That's an excellent question. So the theoretical answer is that if you constantly quantify this business impact, then at one point the marginal impact from a already mature project is maybe smaller than, I don't know, doing some other project instead, right? So it's always relative to something else. What we often see is that, at our scale, we sort of about double the business every year. So even if the benefit becomes very marginal, the size is so big that this marginal improvement will also have huge impact. And that's actually that's the typical context that we operate in. So initially you might, I don't know, improve accuracy, 5, even 10 percentage points. Eventually you do it like 0.1 percentage point. But as the business or the use case is so big, the nominal size of the impact might be even orders of magnitude bigger. So this is sort of one piece, but there are also projects where, either the data that you have just doesn't have this information that you're predicting, or any additional sort of modeling method will not yield any substantial improvements. There's a general human thing that happens in organizations that generally people don't say that, hey, I think next year we should reduce our team size by half because we don't, this is not needed anymore. So this just doesn't happen in day-to-day conversation usually. But actually
just optimizing, downsizing.
In our case, it's actually never downsizing. It's okay. Yeah, let's do this other thing. Yeah. But healthy teams do actually have it. And we've had this as well. Like there are certain, we thought we can solve it with machine learning, but actually it wasn't the machine learning problem. And then we went on to do sort of other things. So this sort of, if we see this happening, it's sort of like a healthy, actually, you understand that this is a healthy team and they're thinking critically about that. But I think as a general human tendency, and it's not like a Bolt specific thing, but what happens in every organization is that people just want to, there's a sort of this inertia that you want to keep on doing the same thing. So you need to sort of self-reflect and think critically also.
Thank you. And I understand that, well, here at the university, when we finish training and achieve state-of-the-art results, then it's like done. But I understand that in Bolt, when you have trained the model, there's a huge work to be done to actually use it. Can you tell us a bit about how you deploy your models and how you run them?
Yes. Bolt is mainly using AWS services. It's using SageMaker, and both Bolt and SageMaker have grown dramatically in terms of size, in terms of capabilities during the same time. So even when we use SageMaker, we actually have our own model lifecycle team internally. So this is sort of like a platform team for data scientists and whoever is sort of building those models to manage the pipelines for training the models, deploying them, monitoring them, sort of everything that's sort of around model lifecycle. The fact that we've been working on this for a while is really great, because data scientists are usually able to come up with the idea, build the model, train the models, deploy them all independently. They just use the internal tooling, and that's sort of like most of cases. But when there are new use cases that we start to solve, let's say we just recently had one with around natural language processing, where we want to classify incoming customer support tickets. This required slightly different approach, and we were, maybe you need to do some custom stuff there. But again, we look at this also as a internal sort of product. So if there are enough data scientists solving that particular problem, we sort of build those tools that make it simpler. So what we've seen is like, this is absolutely wonderful to see that data scientists don't depend on some other team to deploy the models or put them into production. So you can experiment faster, and you can just be more effective.
Oh, that's I think essential to, when the snowfall comes suddenly, then
yes,
you need to react.
Absolutely.
You mentioned natural language processing. Are you using it only for classifying the support tickets, or how is it evolving in Bolt?
This is actually one of the smallest areas, but yeah, we started looking more into customer support area. So there are many things you can do, like you can detect certain types of messages, right? You can detect also personal information data that if you want to mask it from some people, you can detect languages. To be able to, funnel the tickets to right agents. Yeah, this is sort of where we are mostly with it at the moment.
Okay, I mentioned that you're gonna, as you're in so many markets, you need also a lot of different models there, right? So for the language.
Yes, yeah. Although most markets are English speaking, especially in Africa as well, where a lot of the volume is. It's usually the primary language, but yeah, other ones as well.
Oh, okay, so your most of your markets are using Latin alphabet.
Yes.
Oh, okay, that makes it a bit easier, I guess.
Yes.
Okay, there's a question from the audience. Yes, can you please speak up?
Yes, so I would like to ask about
somehow we can't hear you. Let me see.
Do you hear me?
Maybe you can switch the settings.
I'll take a very quick 1 minute break.
Yeah.
I'll be right back.
Yeah. Yeah, I'll try to figure out why I can't hear you. Can someone else try to speak up? So
yes, do you hear me? Do you hear me?
I can hear. I'm not sure if
I think there's something wrong with our side then. Is there a volume button there? Let me just check. Sorry for this disruption. I'll try to change the setting here.
Right, front, left, front.
Okay, can you now try to speak up, please?
Do you hear me? Test, test. Do you hear
just
me?
a second, I'll change the speaker in the Zoom. Okay, no.
Do you hear me?
Sorry again. Can you say something?
Do you hear me?
What's
Test.
happening?
Do you hear me?
ühendada oma telefon sisse ja siis panna telefon loudspeaker'i peale.
I think I have to connect my phone to the Zoom to get your questions because locally our sound works, but it doesn't work for questions from the internet. So just connect my phone to get the
Recording in progress.
Yes, mute, and I'll have to. I'll have to mute this one for a second and have the sound. I muted.
Mikrofoni mute'i või kõlari.
Ma panin kõlari mute'i.
Sa pead siit mikrofoni mute'ima.
Siit ma panin mikrofoni, jah.
Ma panin jah?
Yeah. Change my built-in steering. Okay, I've changed the setting to built-in option, so perhaps you can try now. We are going to
Front, left, right.
Okay, let's take your question.
Test.
Yes, we hear you now.
Yeah, okay, sorry for that.
No.
Do you hear me?
Yes.
Okay, perfect. So how do you set up the human-machine interaction in the business? So do you use the results of machine learning for automatic decision, or is it consumed by some experts? So do you need like some interpretation of models? So how do you create that interaction between machine and human in that sense?
Which interaction do you have in mind?
Like, for example, you have the machine learning results. Do you use the results for automatic decisions, or is it going to some experts so that they just take the decisions and give final result, or?
I guess it really depends what model it is. We have there are so many different things that we predict. So, for example, you can predict the arrival time. So these wouldn't get reviewed by a human. There are very sort of technical maps related things. There are some things around fraud or impersonation, elements where the automatic predictions help to maybe guide human decision. For example, we wouldn't be blocking a driver in some cases, like purely automatically, because their livelihoods depend on this. So we would sort of make a flag them out that they would need something reviewed or so on. So it really depends on what type of prediction and what type of model. But there's this sort of increasingly large use case of what is called sort of human in the loop, that we do it, for example, when we extract text from documents that you need to, for example, let's take the driving license, you need to extract first name, last name, date of birth, driving license number, expiry date, and so forth. And let's say for some of those reads, the confidence is very low. what we can do is push them to human review and then still get a response back from the client side in a fairly quick manner. So these sort of like hybrid flows are actually becoming quite useful, and we're starting to implement them much more in different areas of operations and customer support.
Do you use interpretability or explainability during this process?
In the process where we review individual predictions by the operations team, you mean? Or generally?
By decision, yes. So in any case, so any user who would like to see why this decision is made or something like that.
Yes. So first of all, like it is required also for debugging purposes. So whenever you have some edge cases or you get sort of unusual predictions, you can use the common sort of approaches to understand why a particular prediction was made. Like there's Shapley values, there are other approaches you can do that are sort of model architecture independent. And for individual cases as well, like if it's important to get this result, we can always get. And it's very important that whenever we have a prediction, you need to know what was the model that made that prediction and what was the data that was used to create that model artifact, which we also store and log. So we're able to trace back how this, first of all, how was this data gathered, how was this model trained, and why was that particular prediction made?
So how do you do labeling? So like in that case, do you have like also human experts, or do you have some mechanisms to do it much more efficiently to the labeling of the data?
Most of the labels we already have. So for example, if you want to calculate price elasticity, you have this data from the past, or you can run an experiment to gather that data. Or when you take like maps related things. So if you want to predict arrival times, you know how much it took for the car to arrive historically. And I would say like at the moment, it's for majority of cases, we already have labels. The trickier part is unstructured data, like images and text, where you usually don't have, and there you need to gather it. And Amazon provides different tooling to put out labeling jobs and to label them either with internal workforces or external providers. Many other companies have similarly, and there are also like smaller companies or service providers who help to do it for you. So it's we use them essentially. We have in-house labeling teams. Some of the operations functions also handle labeling, and we also have external labeling partners.
Okay, thank you very much.
But you mentioned often tools. Just if you would mention, from the top of your head, what are the main tools that the data scientist at Bolt is working with? What you mentioned AWS, but just if you would list like 5 tools, most popular, what you hear every day and people are doing with them something.
So we do all of our work in Python world. In terms of sort of modeling methods, for tabular data, we use a lot of gradient boosted trees. Trees in general, we use LightGBM as an implementation of that, which is very quick to train and very relatively lightweight as well. That's very extensively used inside Bolt. Then for deep learning, we use PyTorch mostly, or Fast AI, or some other wrappers around it if it's like quick prototypes. In terms of the sort of this development process and deploying the models and more this model infra side of things, we use SageMaker, but we mostly use custom containers. So all the serving code is usually inside a Docker container, which you just have a Docker file where you specify the local environment where this runs, and you can develop inside of those environments as well. So knowing Docker is really useful. Knowing Bash scripting is really useful to automate all those workflows.
But would a data scientist, so basically data scientists themselves would need to know the Bash, but you know, you can still Google for the open set commands and other stuff, right? But would it be, for example, with Docker? So I'm just curious, how far does it go to the you know, like the system administration part? So they have to understand, you know, I don't know, Docker compose, how to coordinate different Dockers at the same time, or this is already
this is what
the operation team.
Yes, this actually SageMaker handles. We're not hosting the containers internally. We use SageMaker does it all for you. So you just provide a Docker file. You need to build that Docker container. We use Jenkins for that. And then we use Airflow for many different things. So Airflow is like a scheduling tool and you can build these cyclical graphs of different processes. We use that quite heavily, actually, also to build data processing pipelines and also to schedule model training, model deployment, and all those things. So for most of the things, you usually have some template Docker or template project you copy and you sort of modify accordingly, and then you let some other person to review it who maybe knows a bit more. So that's how I actually simulate those. You know, you said usually how it happens is, oh, okay, I need to, you know, I need to install this additional dependency or maybe some binary library inside a Docker container. So how do I do that? Google, hack it together, test it, it works great. But then you run into, okay, I run this model locally. I have this debugging journey that has lasted for 2 weeks right now. That whenever I run exactly the same environment on my local machine, I use. I'm sort of an exceptional one. Mostly people use Mac computers and develop either locally or remotely. I'm using Windows. I mean the Windows subsystem for Linux, which is great. It now has GPU support as well, almost out of the box. So I would encourage you to try it out and learn a bit of Linux as well. So for example, this happens quite often that you build something quick and dirty locally, you put it in a container, but you get different predictions. So then how to debug that, how to debug inside Docker container. But it's not something that you need to have before you join the team. It's usually something that you would never need to do when you study and build your own sort of personal projects. But as with scale, like it's required. So then there are many people who are in the team you can ask from and so on. So.
But do you have also like a training for the newcomers that will pass certain courses for this stuff?
We don't have training. Work, but I've never trained those models or.
Okay.
But if we still continue to talk about the skills, then And I'm still curious on that because especially understanding that like a larger organization, because sometimes even your decisions as a data scientist should be dependent on some things which you don't know. For example, let's say you mentioned AWS, but just to understand, so is there like a say AWS billing optimizer who then runs through all the teams and then tells how to do that, or how do you manage that? Because the AWS billing is basically fixing that can equal sometimes 100 workers.
Yes.
How is that done?
It's handled inside this model lifecycle team because they help with they manage the billing part and give feedback to the teams like, okay, here's your monthly, how much did it cost and so on. And they also work on this sort of additional layer on top of SageMaker to make things more efficient, and that we would use their services in a cost optimal way. And sometimes it requires us to perform a step outside of AWS or do things in a very particular way. But this usually comes from that side because this really becomes an issue for models that are deployed at huge scale, and they're sort of more involved. So you're not sort of personally responsible from your own budget, but you more get support from experienced people who have a more general view.
But is there nowadays like a role, like a AWS billing optimizer in an organization who knows all the product, because the products change, right? So, and all the pricing changes. So somebody who would know how to change it so that basically that everything continues to work the same way as we do, but it's minus 40% of billing.
Yes. In Bolt engineering, we have sort of three distinct areas. So there are product teams who, for example, build the ride-hailing app or the driver app, or some maybe product that even doesn't have an app, like an internal service or so on. Actually, that's not. Yeah, and then there's a second group of engineering teams, which are platform teams. So, for example, Bolt used to rely heavily on the external map providers, but now it has its own internal maps who are at par or better in many of the cities. So there are other services like that as well, where we've used external ones, but then by scale or whatever justification we built internally. And then there's the foundations team who sort of manages the infrastructure. It's a foundations department, actually. So site reliability engineering is there. Building sort of outside of data science, we use Node.js and TypeScript. So they manage all the, essentially they build tooling for other engineers to be effective. And this is, AWS is also largely managed from there because it's much closer to the machines and infra stuff. So that's actually something that makes other teams quite productive, that we've structured it like that. You don't need to in most cases, you don't need to think about this.
Okay, thank you. Last week or 2 weeks ago, we had Josep Pata here from CERN, and for his use case, they're working on a Hadron Collider, detecting particles. It's super important to get near real-time results. So they were training their machine learning models and then building FPGA boards where they put the models into. How important or what's the most real-time use case in Bolt? How important is it?
So everything around the order flow, where you open up an app and you put in your destination, and everything, actually, even when you put in your destination, when you start searching, we try to anticipate what is it that you search and provide you the right sort of thing that you want to search in the results. first of all, this gets huge amount of load because that's what everyone does at the beginning of every sort of order attempt. And then everything after that as well. It's very high load, and it's quite critical to do it quickly, because the longer you wait, the higher the probability that the customer will drop off. So that is quite important to be able to do real time. There are many cases where this is not an issue at all. Like you do some post-processing, you can do it like once a week. You update some user lifetime metrics, like can be daily in some cases. So, but there's a very distinct element, everything around the order flow, like there's fraud prediction, like all these things. Because for a user, it looks very simple ordering, but there are so many processes that happen in parallel on the background. And yeah, that's quite important there.
Yes. But what's the minimum? You want to be like respond in half a second, or what's the minimum?
There's like a quota for every step. So and for different services in that step. So what data scientists usually get is like, here's a time budget.
Okay.
Maybe it's 200 milliseconds, maybe it's 500 in some case. So the prediction needs to happen on average within that time.
So this happens in cooperation between the data scientist and the operations team, right?
It happens usually together with the data scientists and the model lifecycle team, because they handle they configure SageMaker and they handle all the tooling around SageMaker. And that's actually, this latency used to be an important thing why we couldn't run some prediction models on their sort of default infrastructure. And what we probably see also in the future is that once these systems become more complicated and the scale becomes even larger, then there's even more incentives to build our own custom solutions, because you can then better control the latency element and also some things that you want to maybe have your own way rather than SageMaker way.
Okay, thank you. And I think this will be changing for you as your main business is in driving cars around the city. Today you're using lots of drivers, but in 10 years perhaps more the cars are driving by themselves. So are there any news to share on Bolt's?
Yeah, so Bolt funded this self-driving project research with Tartu University and this was largely done to explore the viability of self-driving, autonomous driving for ride-hailing services and just generally as well. And the aim wasn't to build like the leading self-driving technology, but you need to, in order to test and validate all these methods, like there's loads around safety, around high definition maps, how do you update those maps and so forth. You need to have a vehicle on the street. And the learnings from that have been, this is not specific to that project, it's learnings in general. So the interesting thing with the autonomous driving and like self-driving taxis is it has always been 5 years in the future for the last 30 years. And it's still 5 years in the future. So that's the key summary. But maybe one of the interesting highlights is that Waymo has been the first operator to offer a fully autonomous taxi service in the suburbs of Phoenix in the US. And there's this paradox with self-driving that in the suburbs it's great. You can deploy your fleet because there's not much traffic, but the majority of business is in high density center areas where there's scarce parking, people, really aggressive traffic, people running on the streets. And this is the most difficult problem to solve for self-driving. And this would be required. I mean, this is where all the business is, right? And for any of those self-driving companies to be commercially viable, they would probably need to solve that problem for self-driving taxis. But this is still in the future. And even Waymo is not expanding at the moment outside of their this very highly controlled, highly mapped suburban area.
Yeah, I understand that it's for them they need to demonstrate that their system, that all those hundreds of millions of dollars invested have some result. But yes, those suburbs in the USA, they often don't have any street walks, so no pedestrians.
Yes.
You can,
but there are interesting sort of other areas related to self-driving. For example, Bolt has huge fleets of drivers in the cities. And we have our internal maps as well, which we need to update. Like we need to know specifically, usually for regular people, including me before joining Bolt, like I was using Google Maps and, it would immediately pin down the right address, right? And this is true for some of the cities like in Europe and in the US. But when you go to Africa, or maybe some of the countries in Europe even where things are, Google hasn't sort of reached that level yet, you don't even have the street numbers, or sometimes there are even no street numbers. They have like names for buildings. You need to, if you want to dispatch your drivers, you need to know where to dispatch them to and provide a good service for users. So what we have started to do is improve our own internal maps. And for that, we can, for example, use the fleet of cars and put the cameras on them to gather images when they drive. And we can map those images and do automatic recognition of like points of interests, street signs, even detect one-way streets, detect turn restrictions to provide better routing. Which is quite related to how autonomous driving companies would need to update their maps as well, because that's still the key sort of requirement, that you need to have really up-to-date, high-quality, high-definition maps. So this was, for example, something that was quite interesting out of that research. And Bolt is also it's actually using some vendors to do the first pilots for that, but it's an area that will become increasingly more important.
So you are in an excellent position to actually solve the puzzle of self-driving.
I don't know. It's such a complicated problem that there are so many things to solve in there, and I think it's just like we need to scientifically improve on so many different fronts before that can happen reliably.
Yeah, that's actually wanted to get to, is that when we look at the top conferences for computer vision, for example, and so there are a few universities, MIT, Stanford, perhaps a few others, but most of the top papers, or not most, but at least many, I think most actually, are coming from companies like Google, Facebook AI, now Meta AI. And do you have any plans for Bolt research or?
We have had people publishing papers under Bolt as well, because you need to state your affiliation, right? But we are not planning to do research for research sake. When something comes out from Bolt that has some academic value, then sure, why not? But we're not knowingly aiming to do that. There are some people who have researched a topic related to us and have used Bolt as a have used Bolt data or tried to solve it for Bolt, but we don't have a specific goal for that.
You're not at that stage yet.
Yes. I mean, you don't need to be at that stage. So many companies do it for sort of like this public perception, and some companies do actually have their own research, but we don't. For the things that we do right now and the scale at which we do them, we're mostly just adopting what is out there. And sometimes we also innovate on those things, but they're not like big or so big that you would write a paper on this. Or sometimes people are just limited.
Yeah, my observation is, for example, that often many great papers come out of the companies because exactly as you said before, they're looking at the problems, not at some benchmark. And when evaluating different methods, they see that everyone else is doing it wrong. So, for example, at the end of 2017, early 18, Apple, two scientists published VoxelNet for LiDAR point cloud recognition, and this is a groundbreaking work. What they did is essentially everyone else was working for the benchmark, but they needed something fast, actually deploy on the car. So while solving this practical problem, they came up with a novel solution that changed the scene.
There are actually, we're discussing this internally as well. Like we have great people across the globe and who come from academic backgrounds as well, and we have identified a couple of topics actually that we could publish, but it's a lot of work.
It is
to do it, and but I'm like this can happen in the future. I think the bigger the organization grows, the more we would have these resources as well. But generally, like there you can also publish these articles for more like PR purposes, and many companies are doing that. So we try not to do that, but there's some things, for example, maybe around geospatial data that we have quite good insights into. And for example, why tree-based models work better there than deep learning models. We've had quite interesting discussions and experiments there as well. Or why that is actually. Why do they perform better? I think there's a question.
Ants, you.
Yes, I have a related question. How big of a part of the work involved these research-related kind of developing novel methods and such, and how big of a part is kind of applying standard methods?
So mostly we rely on whatever is out there, because again, we don't need the last sort of % improvement, but we need a solution that is tested, that is scalable, and sort of well manageable. But for some it's more in the mature teams where we have had the team of data scientists already for 3-4 years, where we're really looking for this, the last sort of marginal improvements as well. And there, we do have some implementations that we haven't seen elsewhere, but we're not actively working on publishing them. But majority of work is around more finding the right method, business problem fit, and the engineering solution for it. Which is great because you can go through so many different methods.
Compare them.
Yes, and that's actually that is the knowledge that is most valuable. Also, when we have like incoming data scientists from other teams, you can see that people with excellent technical background can propose very sophisticated solutions, but there's this other solution that is 10 times easier, scales much better, and it's just much better to work with. And this is knowledge that is so hard to come by unless you have worked in a similar environment before. And this is actually a really valuable thing to learn in a company like that, because you cannot. it's hard to learn otherwise.
From which countries the main data scientists are coming from? We have like
We have a team in Estonia. So there are 2 engineering hubs in Estonia, Tallinn and Tartu. Tartu is quite big as well. Tallinn is a bit bigger. We have one in Bucharest in Romania. We have engineering hub in Warsaw as well, but we don't have data scientists there yet. So that's one of the plans. But people there are not only locally, so we have many people from Russia, from Ukraine, from quite many people from the UK. We have, for example, in our team, one guy from US, Italy, Brazil.
Are they working remote or?
No, from here.
Okay. But how would it work? Like, how would data science function work, like remote or in a hybrid way?
It works like every other engineering, I think, not like every other. So the way that data science is different from regular engineering is that you need to know quite a lot from the business side, because if you want to solve a problem end to end, you need to, be able to experiment and sort of understand what the user experience is. I mean, this is something that every software engineer ideally would do, but the expectations are higher for data scientists. What we've seen is remote works quite well for mature teams, because you already have the trust in between the people, and then it's just important that you get together after a while, like every month or every quarter. But for new people, when you onboard, it's very beneficial if you can work at whatever engineering hub there is, but for both internally. But what we see as well is we are already getting the people move in between teams, and there are so many teams created that majority of teams are already distributed between like Tallinn, Tartu, Bucharest, Warsaw. There might be some people like working remotely from Kärkla or from Cluj in Romania. So it's already quite so remote sort of ready. We don't do full remote yet, but we do sort of do remote in the engineering hubs that we're at, in the countries where we have engineering hubs.
Maybe a quick educational question, or like a trick question. So for you as a data scientist to say something in favor of the other fields. So my claim is that the teaching or the development of data science has become, it's very popular, but it has basically become in a way on the expense of what I would say that decision science or operational research, optimization, and so on. So what's your take for the future? But basically, if you would have budget allocations, what would you say that there should be more optimization, teaching kind of things, even if it would come out of expense of data science? Or how would you balance that? My claim would be that currently the pedal is pushed until the limit with the data science on the expense of optimization. But now, especially since you mentioned that there are a lot of like optimization problems, which are not predictions but optimizations, and how would you comment those interplays?
So we internally see operations research as part of the work that data scientists do, and we have some of the data scientists who actually come mostly from operations research background. For example, in financial planning, you need to optimize budgets, so it's very straightforward problem there. Dispatching as well. So we don't look at these as separate things. Also, I think data science has been just a very sort of romanticized title. It can mean a lot of things. For some companies, it means just a glorified data analyst. In other teams, it's like, it's more closely related to engineering, or some teams actually do more on the experimentation side. what I'm seeing is that there will become more specialized roles. Like I think what's happening already is that, and what we see inside Bolt as well, is that we have data scientists who are sort of like generalists. They're able to, they know on high level they can implement whatever model. They can write the code for it to happen and like all the deployment. They can run experiments, even maybe some more complicated experiments. And they're able to communicate very clearly and speak with the product in a level that they understand as well. But these are like huge areas, and you can actually go very deep in each part of those. And what we probably will have is like, for example, maybe we need a machine learning engineer who will squeeze the latest bit out of the predicting the arrival times, for example, because the bigger your scale, the more complexity, the more, the harder it becomes. And for example, on the experimentation side, we're also getting into more complicated experimentation strategies that will optimize your budget during the same time as you're running the experiments. Then on the operations research part, this financial planning is crucial that you do like good decisions. And there we actually have like a small data problem that like all the budgets are monthly and you don't have these huge volumes, but how do you still make the good data and how do you, good predictions, and how do you optimize it considering different sort of horizons?
But not with PyTorch. For that, it's completely,
yes,
and we don't research it. The tools are different, right?
Exactly, and we don't put limits on there. So there are like most people don't use PyTorch in Bolt. It's like usually the computer vision or natural language process. Even there, you don't need use some simpler things. So it really depends. Like the profiles under data scientists are very different that we look for. But I do absolutely agree that this machine learning and deep learning is sort of hype and sort of sexy thing, but the value comes many times. The value comes out from these optimizations, which are more maybe not the first thing that people start learning when they decide to go into this sort of data science world. And this was what I was heavily influenced in TalTech as well. There's Eval Tibi was the first person that got me really excited about this. And Jan is his son, right? So he brought in the programming side of this, and this is like hugely valuable, but people that just don't maybe realize this.
Thank you. We have a question that's somehow related to the one of the previous ones. Is that are you using any kind of explainable AI or interpretable machine learning techniques for deep learning?
Yes.
Specifically.
Yes. So these Shapley values is one thing that we've. These are agnostic to any of the models. There are these. I think PyTorch. No, TensorBoard is offering to like this tool also to predict, like explain those predictions. So yes, we are. So this explainability is also like explain to whom. So for me, it's pretty understandable like how did prediction come by, right? But you also need to understand to whom you need to explain it to.
Yeah. I guess there are two distinctions. One is that your customer asks, "Why did you block me?" and you need to explain that. And the other is that your model predicted that this car is a tram, and then you need to find out why it misbehaved.
Yeah.
So yeah, I've been using Captum, the PyTorch Captum, which implements many models where you can see where the error originates from, which layer or from which part of the training data. But yeah, I guess there are many ways to. You often don't have to go that deep to understand the problem.
and oftentimes, like, you don't need to really, for example, when you do text recognition, like you just know you made an error, right? You just add a bit more correct labels, and then usually it's sort of we don't often build very custom architectures. At least the baseline model is usually you take some backbone and retrain it, and sort of works. And then you either add more labels, or then you can actually go into more specific architecture as well.
Okay, thank you. Are there any more questions from the online audience, or from real life? I don't know how to say online and in present.
Before you said that you have to take all this weather and traffic into account when making predictions, but do you use some external information or forecasts, or maybe Google Maps or Waze data for traffic jams or weather forecasts for predicting snow or something like that?
To predict weather, or to predict the impact of weather on traffic?
Yeah, to predict the impact.
So first, like a general comment is that this is something that we have discussed for a very long time, and we've run many experiments on this. So it depends on how far do you need to predict traffic, and usually for our case we need to predict traffic for the next 10 to 60 minutes. And for that, it really doesn't matter that much, because first of all, you cannot forecast weather with that accuracy. But when you do longer predictions, then we've done different tests, and there are, I can't be very specific, but we're considering it. Yeah, it's more for this hot traffic thing that you're sometimes the routing changes when the weather changes. So I mean, in principle, everything has merit, but it's just like you have limited resources, and have you exhausted all the other means that are more powerful before that one? Weather is not that powerful because of the technicality of what horizon do you predict.
For example, traffic jams. Maybe there's a car crash on Mountain.
Yes.
Do you understand it from your own data, or do you get some external information as well?
For this live traffic, we use our own. So it depends on its. So we have our own map service internally, but we also have, for redundancy and for many other reasons, we have integrations to some other map providers as well. And the way we decide actually which one we use when is different in different cities. So it's potentially available from those. Additional information is potentially available from other map providers, but the way we decide when we use that is sort of commercially driven. So we know in which cities and where we have the accuracy better internally, and when we have it better externally. So there's this layer as well. But we have it from external providers. We have it available from external providers.
How would it be different working with different cities? Does it feel like working with data from Tallinn is somehow easier or more relatable than working with data from Johannesburg?
Yes, and that's a big problem because Tallinn is not like the rest of the world. I mean, of course, what we do is whenever we are coming up with a new model or we want to test something, we don't test only in Tallinn. We usually test also in Tallinn because we can get the real world sort of feedback, experience it ourselves in some cases. But when we do rollouts or decide whether to roll out this particular improvement, we do more global tests. So not only in Tallinn. Usually we have some cities we know are usually behave differently or they have their own specifics. So yeah.
Okay, we covered quite a lot of topics. Are there any others to touch? When I came here earlier, I thought that it would be appropriate to use Bolt, and as I was running short of time, I didn't want to use this driver app. The driver version, I looked for Bolt Drive, and there wasn't any in a half a kilometer range. I can say that the nearest city B was even further away. So, but my last question would be that how long it takes for me to open the app and not finding any car in the nearby, for you to discover that I wanted to use a car and didn't have any, and then do something about it?
Like propose to take a taxi or
no, I mean how long it takes for you to improve your business so that next time I'll be opening my app before the lecture, then I'll have a car closer by.
So this is sort of the availability of cars. It will probably be inevitable that in certain conditions you don't just have a car. With dispatch, with ride hailing, it's easier problem. Like it's a bit more easier to solve problem because you can alter the dispatching, you can incentivize drivers, like give them bonuses to be online at certain times. With Bolt Drive, it's more like you just need to have more cars. And that's what we're planning to do. So we already have the largest fleet in Tallinn. And the plan is to scale it out quite significantly because it's been like a really, really good success. That people really value and want.
I think it's the same problem with cars and scooters, that in Tallinn everyone drives them to the city center in the morning, and then there are none.
Yeah, I mean, it's a very interesting problem for those, we call them rentals, so scooters and cars alike. The logic is similar between them, that you just deploy the fleet somehow, and then you have to answer two questions: when to pick up a car or a scooter, and when and where to drop it off. And you can actually have a lot of complexity behind it. So first of all, like quality assurance, like cars have fuel, right? So how do you plan for that? How do you predict the demand in that area? How do you the demand prediction and the likelihood of that car being utilized in the future is quite important. And then when you drop off, when you deploy the scooters, which is done in batches, or when you redeploy the car somewhere else, what's the like you can keep the car there, or what's the alternative cost if you move it elsewhere, and where to then? So this is more this operations research problem. It has nothing to do with deep learning, right? But it's a hugely valuable approach to answer those questions. And you need to do it at scale automatically manually. So
I can count on Bolt already working, getting a car closer to me next time.
Hopefully, yeah. So the majority of impact will come from purely increasing the fleet. But once the fleets are sizable enough, then all those optimizations become even more worthy, move up in the priority of what needs to be done.
Thank you.
Thank you.
And thank you, Siim, for joining us.
Yes.
And thank you everyone who's here and who's online. We had a nice hour and a half. And this was the final session for this semester. And have a happy holidays, everyone.
Thank you. Thanks for inviting. Good discussion.